Hi guys, Mr. Johnny here, just a quick video showing what I do at the moment. And at the moment you can see the soldering station working just fine there, although you did not see those videos yet. But the power supplies that I made for it, which you've seen a few videos about already on the channel, is working there just fine, and I used it for a few weeks now flawlessly. After I chased some little gremlins around, but that's not a big deal. Topic of this video is, you may have seen my previous project, and that is this kind of power supply. Flyback around UC3840 series family. UC3844 installed right there. As you can see this board is quite chunky and yeah, not ideal layout. It's a prototype but you can see that I realize that flyback has ridiculous amount of peak currents in the secondary side, in the primary side as well, but secondary side is just enormous. The peak amplitude of the current ripple in the secondary side can reach 5 times your output current. It's just freaking disgusting, but whatever. You can see now this board doesn't have a transformer. I was experimenting with it. I had an enormous amount of noise produced by this board. I fixed that somewhat by rewinding a transformer. This one is a DCM, discontinuous conduction mode, discontinuous current mode, whatever. I made one more like this to put that board into the CCM, continuous current mode, and the ridiculous amount of interference dropped down a little bit, but that was still quite pesky, so I rerun the board. Now it looks more like a laptop adapter than something made by the hobbyist. As you can see, this new board is smaller. It's less wide, it's less long. It has this little it's quite a decent heatsink actually. It has this heatsink which wraps around in a weird fashion, utilizing the maximum kind of space I can for the unit to be compact and to have the maximum square area of this heatsink, so it can dissipate the power easily. This power supply has everything a power supply should have, really, except the fuse at the moment, because I ran out of those small fuses, so I just put a jumper there. I'm gonna use it with a fuse dangling on the wire lead itself. It's not a big deal for me. You can see an interference suppression capacitor, common mode choke there, thermistor, NTC there. Focus, you moron. Bridge, bulk capacitor, some more components there, the actual chip, some components around it. You can see switching transistor and an RCD clamp hidden right there. That is actually for a reason. That clamp circuit, along with the drain of the MOSFET, is pretty noisy node, so, and this heatsink will be earthed, it will be grounded, so it's not only acts as a heatsink but also acts as a shield for the RCD clamp, for the transformer, and for RC snubber across the rectifier, which I don't need actually, because I run some tests on it. It works just fine. The waveforms are clean enough without the snubber. The layout is quite a lot different. This board produces much less EMI. As you can see, still a nice separation. You can see fat white traces there. That's a drain. This is one end of the primary, and that's a drain of the MOSFET. See how short it is. And on this board, that's primary, and that's drain. It's ridiculous. It's an antenna. This one is just a half a BSD clone. It's not a big deal. There are some SMD parts there that I included just for the convenience. Remember, I do make most of my projects in a weird fashion. Normal people usually come up with an idea and buy parts for that project. I do it in the crooked way. I buy parts that I like in the shop, then I try to cobble a project from them. That being said, these capacitors are not the ones I plan to install as well. I ripped them out of the PC motherboard, but they work. And it also has an LED there, indicator. Proper optocoupler feedback. Shut up. And the focus, you moron! God damn it! And the interference suppression capacitor there. Using TL431 as an error amplifier. Works quite good. The efficiency under full load, well actually more than full load. Let me reset the A name because it's a wimpy little bitch. It's designed to be 12 volts 3 amps. I load it up with 3.6 amps and the efficiency is 90%. How about that? No load consumption is about 1 watt. I'm gonna demonstrate you right now. You can see there. 1.2 watts. Let me hook up the bulb. Okay, so that's a contraption. As you can see, I'm using one hand already, so I'm gonna plug it in and then show you. Okay, the lamp is there glowing bright. As you can see, we are 12.15, 3.6 amps, and 48.7 watts, as you can see. It's close to 90%, approaching it. Okay, and another thing that is great about this power supply, it's using UC3844 chip. It's a current mode controller. Current mode controllers, PWM controllers, they have an inherent short circuit protection because they need a current ramp for the correct operation. So they have the little sense resistor, well, quite big sense resistor anyway. So they have sense resistor in the source of the MOSFET. They monitor the current all the time. So these kind of supplies are inherently short circuit protected. To demonstrate, you see the LED is lit. I'll put the meter there. I'm gonna short it out. It just ticks. And it's not even warm after that. It is excellent power supply. I'm really happy that I made this board, because now if I need this kind of similar switch mode power supply, I'm gonna use this, made one more of these boards, maybe modify the values a little bit, like 15 volts or whatever, or 9 volts. You get the idea. This board is a good platform to build some power supplies on. So that's that. Schematic you will see in the next video. I did change it just the slightest bit. If you're, as I said, impatient, you can use the schematic from the previous video. You're gonna see the link for that video in the description. And yeah, so that's that. Thanks for watching. See you.